Okay, hey, welcome back, class. Today we're going to start doing some practice problems when it comes to average atomic mass. Some key indicators and understanding average atomic mass, just a quick refresher. Remember, it's the percent abundance of isotope of whatever element. So we can say, let's say element has two isotopes. Okay, so we can say percent abundance of isotope 1, and we multiply it by the atomic mass of that isotope. So we would say percent abundance of isotope 1 times atomic mass of isotope 1, and then we're going to add that and do the same thing for isotope 2. And now here's a helpful hint for when we do average atomic mass. One key thing that you might want to realize if you haven't already, when working these types of problems out, you're going to realize that, hey, once I add all the atomic masses up after I've done the percent abundance and I've done the isotopes and all that, it's going to be really close to the atomic mass listed on the periodic table. That's on purpose. If you're far off, then your math is probably wrong. In saying that, let's work out some of these practice problems. I got 4 of them for you, and we'll just work through them. So our first one is naturally occurring boron is 80.2% boron 11 and 19.8% boron 10. To be more precise, the atomic mass of boron 10 is 9.737 atomic mass units. Determine the average atomic mass for all the isotopes of boron. So how do we go at this? So first we're going to convert our percentiles to decimal numbers, because we can't just go in there and multiply our percents in there. So our 80.2%, we're going to move our decimal place to the left 2 places, and that's going to give us 0.802. And our 19.8%, if we move our decimal place to the left 2 places, that's going to give us 0.198. Now that we have our percentages converted to decimals, we can start plugging them in and playing with the equation. So we're going to take boron 11. We know boron 11's atomic mass is 11.0. We're going to multiply it by its percentage, decimal, which is 0.802, and we're going to get 8.822. Okay, we're going to hold on to that number for a minute. Now let's go down to boron 10. Okay, boron 10 has an atomic mass of 9.737. And we're going to multiply that by the 19.8% decimal, which is 0.198. So when we multiply 9.737 by 0.198, we get 1.928. Now all we have to do is add what we got for boron 10 and boron 11 together, and we get 10.75, which is close to what boron's atomic mass is on the periodic table. So that's how we know we got it right. Now let's go to the next one. Argon has 3 naturally occurring isotopes: argon 36, argon 38, and argon 40. Their respective atomic masses to 2 decimal places are the following. Argon 36 is 35.97 atomic mass units. Argon 38 is 37.96 atomic mass units. And argon 40 is 39.96 atomic mass units. Their percent abundance are 0.337% for argon 36, 0.063% for argon 38, and 99.6% for argon 40. Given this information, what is the average atomic mass for argon and all of its isotopes? So this one we're going to it's important, like, okay, we're given multiple ones here. You probably want to write down this in a chart to kind of keep it organized. So argon 36, its atomic mass is 35.97. I'm going to multiply that by its percentage converted to a decimal. So I took the 0.337%, converted it to a decimal. That gives me 0.00337. So whenever I multiply 35.97 times 0.0037, I get 0.1212. So that's argon 36. Let's go to argon 38. So its atomic mass is 37.96. Once I convert its percentile to a decimal, I get 0.00063. So 37.96 times 0.00063, that's going to give me 0.0239. Now finally for argon 40, we have its atomic mass is 39.96. Then we multiply it by its percentile converted to a decimal, which is 0.996, and that's going to give us 39.8002. Now we add what we got up for all three isotopes of argon, and we get an average atomic mass of 39.9452, which is close to what's on the periodic table. Now let's go to carbon. Let's work on with carbon. Carbon has two isotopes, carbon 12 and carbon 13. Carbon 12's atomic mass is 12.0, and it occurs at a 98.89% abundance, while carbon 13 has an atomic mass of 13.003 and occurs at roughly about a 1.10% abundance. Calculate the average atomic mass for carbon and its isotopes. So I just do this. I got carbon 12. Its atomic mass is 12. I multiply it by its percentile converted to a decimal, which is 0.9889. After that, I get 11.8668. Then we go to carbon 13. I take its atomic mass of 13.003, times it by its percent abundance converted to a decimal, which is 0.0110, which gives me 0.143. So I add both those together, the 11.8668 and the 0.143, and I get an average atomic mass of 12.001. Okay, last one. Magnesium has three isotopes, magnesium 24, magnesium 25, and magnesium 26. Their respective atomic masses are 23.98 for magnesium 24, 24.98 for magnesium 25, and 25.98 for magnesium 26. Magnesium 26 naturally occurs at 11.01% abundance out of all magnesium. Magnesium 25 occurs at about 10% abundance out of all magnesium, and then magnesium 24 occurs at a 78.99% abundance out of all the naturally occurring magnesium. Determine the average atomic mass for magnesium and all of its isotopes. So we just go through this once again. Magnesium 24, its atomic mass is 23.98. I multiply it by its percent abundance converted to a decimal, which is 0.7899, and I get 18.7418. Then we go down to magnesium 25. Its atomic mass is 24.98, and I'm going to multiply that by its percent abundance converted to a decimal, which is 0.1. So that's going to give me 2.498. And then finally, magnesium 26. We get its atomic mass is 25.98, and we multiply it by its percent abundance converted to a decimal, which is 0.1101, and we get 2.8604. When we add all our magnesium 24, 5, and 6 together, we get 24.3 atomic mass units for the average atomic mass. And saying all that, I hope these few worked out solutions kind of help you and get you an idea how to work these types of problems. Yes, it does involve math. And yes, it can be extensive at times. But if you just follow the formula and just break it down to each individual isotope of an element, it's not that bad. So, again, I hope this helps, and keep up the good work in your class, and see you next time.